Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at everything you need to know for the upcoming test, which is on expanding and factorising. So expanding is when you have a set of one or two brackets like this and you end up with an answer that has no brackets. So expanding is going this way, starting with brackets, ending up with no brackets. Factorising is going the opposite way. Factorising is where we start with an expression and we write it as something times something, i.e. the product of factors. For factorising, we start with no brackets, end up with brackets. So expanding and factorising undo each other just like addition and subtraction. If you start with something and expand it, then factorise, you're back to where you started. So let's look at the expanding. So we'll start by looking at expanding one bracket. So to expand this, we use the distributive law. The distributive law says you distribute what's outside the brackets to everything inside the brackets. So we go 2x times 3x, 2 times 3 is 6, x times x is x squared. So now we go 2x times negative x squared. Well, you know from our index laws topic that x times x squared gives you x cubed, and we also have 2 times negative 1 gives negative 2. So this is negative 2x cubed, and then we distribute the 2x to the y. 2x times positive y is just 2xy, and we're done. All right, let's now look at expanding two sets of brackets. So when we are expanding two sets of brackets at once, called binomial expansions, we use the FOIL method. The idea is we need to multiply everything in the first bracket by everything in the second bracket. So we need to multiply x by x plus 5, then we need to multiply 3 by x plus 5. The FOIL acronym helps us keep track of what we're multiplying by what. So F stands for first. We multiply the thing first in each bracket, so x times x gives us x squared. Thing on the outside of each bracket, so that's x times 5, which just gives us positive 5x. Insides is 3 times x, so that's just 3x. And last, the thing that occurs last in each bracket, 3 times 5 is just 15. So after you've expanded, you need to see whether or not you can simplify. So here we have 4 terms, and we look for any like terms. So 5x and 3x are like terms because they both contain 1x. So 5x plus 3x just becomes 8x. So our final answer, x squared plus 8x plus 15, and we're done. All right, let's look at this second example. Let's use FOIL again. So first, x times x is again x squared. Outsides, x times 6. Insides is negative 6 times x. And then the thing last in each bracket's negative 6 times 6. So again, we look for like terms. 6x and negative 6x are like terms. 6x minus 6x is actually just 0. So those two terms cancel out, and our answer is just x squared minus 36. So let's look at this example here. So the thing first in each bracket's 2x times 3x is 6x squared. 2 times 3 is 6, x times x is x squared. So outside's 2x times negative 4, insides is negative 5 times 3x, and then last in each bracket's negative 5 times negative 4 gives a positive answer. So then we have like terms again, negative 8x subtract 15x. So negative 8 subtract 15 is negative 23. So in the middle is negative 23x, and that's our final answer. So when you have a perfect binomial square here, remember that squaring is the same as multiplying something by itself. So x minus 10 squared is just x minus 10 multiplied by itself. So now we can use FOIL. First in each bracket, x times x. Outsides, x times negative 10. Insides, negative 10 times x. And last is negative 10 times negative 10, 2 negatives multiplied or positive. So note, these two terms don't cancel out. Negative 10 subtract 10 isn't 0, it's negative 20. So I'm going to replace the negative 10x and negative 10x with negative 20x. Whenever you have a perfect binomial square, you always have 3 terms. So the final answer is x squared minus 20x plus 100. All right, let's now look at some factorising. So here we're going to factorise mostly quadratics. Quadratics are just expressions with an x squared term. So there are 2 types. Quadratics that have 2 terms and those that have 3 terms. If there are only 2 terms, ask yourself if there's a common factor. If there's a common factor, use highest common factor method. If no common factor, use difference of 2 squares. So this expression here has 2 terms. Although it's not a quadratic, we're going to use the highest common factor method. How do I know to use that? Well, the 2 terms here have common factors. Both of them have a common factor of 5. They also have an x in common. So for highest common factor method, you write the highest common factor outside the brackets. And inside the brackets, we're going to divide each term by the highest common factor. So what do I times by 5x to get 5xy? Well, that's just y. What do I times by 5x to get negative 20x? Well, that's just negative 4. So factorising is the opposite of expanding. If I expand my answer, I get what I started with. All right, this expression here is a quadratic because it has an x squared term. It has 2 terms. Those terms have a common factor. 4 and 2 share a common factor of 2. Both terms also have a common factor of x. So what do I times by 2x to get 4x squared? Well, I need to times by another 2x. What do I times by 2x to get negative 2x? Well, that's just negative 1, and we're done. So let's look at these 2 here. So for x squared minus 16, it's a quadratic, and I have 2 terms. But neither term shares a common factor. There is nothing that goes into x squared that also goes into 16 other than 1. So I can't use highest common factor method. If there's no common factor method, we're going to try difference of 2 squares. In fact, this is the difference of 2 squares because it's perfect square minus a perfect square. In maths, difference means minus. So when you have a perfect square minus a perfect square, difference of 2 squares, set up 2 brackets. Square root the first, so square root of x squared is x. Square root the second term, so square root of 16 is 4. 1 bracket gets a plus, 1 gets a minus. It doesn't matter if you write the minus or the plus first. We are multiplying these 2 factors. Doesn't matter the order in which you multiply. All right, 49x squared minus 25. There are no common factors. No numbers go into 49 that also go into 25, other than 1. So difference of 2 squares, we set up 2 brackets. We square root the first, so square root of 49x squared is 7x. Square root of 25 is 5. 1 bracket gets a minus, 1 gets a plus. So if you were to expand either of these using FOIL, you would get what you started with. So that's all well and good for 2 terms. What about when there are 3 terms? Well, there's only one method we have called the sum and the product rule. So when you have 3 terms, set up 2 brackets like this, and then we're going to put an x in each of them. Now, it's called the sum and product rule because the numbers that go here and here inside the brackets are the 2 numbers that multiply to the constant term, the term with no x's, and add to the coefficient of x. The 2 numbers that multiply to 16 and add to 10 are 8 and 2. So we put 8 and 2 in there. All right, let's look at x squared minus 14x plus 49. So it's got 3 terms again, so we'll set up both our brackets, and we'll put an x in each. Okay, now we need to find 2 numbers that multiply to 49 and add to negative 14. Well, both of those numbers are negative 7. Negative 7 times negative 7 gives positive 49. Negative 7 plus negative 7 equals negative 14. If you were to expand this using FOIL, you would get that. So let's look at this last example here. So this one's a bit different because there is a number in front of the x squared. When that happens, you need to first take out a common factor. See, 2x squared, 2x, and negative 24, each of those 3 terms shares a common factor of 2. So I'll write 2 out the front. So what do I times by 2 to get 2x squared? I just times x squared. What do I times by 2 to get to 2x? Well, that's just x. What do I times by 2 to get negative 24? Well, that's just negative 12. So we've used the highest common factor method. Now we have a resultant quadratic with 3 terms. So I can factorize this further. I'm going to leave the 2 alone. I'm just going to factorize what's been underlined with blue. Well, I have 3 terms, so the way I'm going to factorize what's underlined, I'm going to set up 2 brackets with an x in each brackets. So I need to find 2 numbers that multiply -12 and add to 1. So if we go through factors of 12, we'll see 4 and 3 work if I make 4 positive and 3 negative. Because 4 times -3 is -12, 4 plus -3 is 1. And the coefficient of x, if it's not written, is just 1. All right, let's look at some worded problems now. So, firstly, we're asked to find which numbers go in the boxes here. We'll note these 2 numbers must multiply to the constant term. So 3 times what is -15? Well, that's just going to be -15 divided by 3. What goes in here has to be -5 because 3 times -5 is -15. So if I were to go through and do FOIL and expand this, we'd find that the number in front of x here would be 3 plus -5, which is -2. So I'm done. All right, let's look at a harder question here. So we're asked to calculate the area of the path in terms of x. So we have this block of land and we have a pool in the middle. So the area of the whole block of land is x plus 20 the length times the width x plus 15. So what we need to do to find the area of the path, we need to take the area of this block of land and subtract the area of the pool. So what's the area of the pool going to be? Well, it's x plus 15 from here to here, but we need to take away 2 lots of x. X here is the width of the path. So the width of the pool will be x plus 15 minus 2x. So x 2x is just -x. We leave the 15 alone because it has no like terms. So that is the width of the pool. What would the length of the pool be? Well, it would be very similar. It would be x plus 20 minus 1x minus 2x. So it would be minus x plus 20. All right, let's now go through and expand these brackets. So let's start by expanding this using FOIL. So, expanding this using FOIL, I get x squared plus 35x plus 300. Just by going x times 15, 20 times x, 20 times 15. Now let's expand this using FOIL. So I'll leave the minus here. So using FOIL for this, which is a bit more tricky, -x times -x, I get x squared again. Then I get -x times 20, -20x, 15 times -x, -15x, so I end up with -35x, and then the last term is again 15 times 20, which is 300. So what am I left with when I expand this out? Well, I have x squared minus x squared. This minus applies to everything in here. So x squared minus x squared is just 0. They cancel each other out. Similarly, 300 minus 300, they cancel each other out. It's just 0. So what I'm left with is 35x minus -35x. So that just gives me 70x. So the area of the path in terms of x is just 70x. All right, let's look at one more worded question, then we're done. So we're told a square with side length x, we're going to increase its length by 3, decrease its width by 3, then we're asked will its area increase or decrease, then we're going to find the perimeter of the square. So if not given a diagram, let's draw one. So we have this square here, its side length is x. So we're first told we're going to increase the length by 3. So we're going to take this length and increase it by 3. But what we're going to do is decrease the width by 3. So what's going to happen is we're going to end up having this blue rectangle here. So the length will be x plus 3. The width will be x, that was the original width, subtract 3. So the area of this rectangle is x plus 3 times x minus 3. So expanding this using FOIL, we get x times x is x squared, First, outsides is x times negative 3, insides is 3 times x, and last is 3 times negative 3. These two cancel out. Negative 3 plus 3 is 0. So the area of the rectangle is x squared minus 9. So the area of the square originally would just be x times x, which is x squared. So the area of the rectangle has been decreased by 9 units. It's whatever the area of the square was, subtract 9. So clearly, increasing the length by 3, decreasing the width by 3, has decreased the area by 9 units. So if the area of the rectangle is 27, what's the perimeter of the square? Well, to know the perimeter of the square, we need to know the side length of the square, and that's x. So we know the area of the rectangle is x squared minus 9, but we're told that the area is 27. So if we add 9 to both sides and then square root, we get x equals 6. That means the side length of the square is 6. So the original square was 6 by 6. We changed the square, so it was now 9 by 3. 9 times 3 is 27. So the original side length of the square was 6, so the perimeter is just 4 times 6, which will be 24 centimeters. Alright, thank you so much for tuning into this video. Best of luck studying. This has been the luckiest maths teacher in the world. Have a great day.